One time when I was in Mexico, I went to work out at the hotel gym, and then after I went to work out, I wanted to go into the sauna. So I went and asked the lady who was working the desk if I could have a towel. Now, I asked in English because the hotel where I was staying, I assumed everybody spoke English. She comes back and gives me a hand towel. Maybe I didn't ask for the right one, so I asked for like a big towel, and she comes back and she gives me another hand towel. So I was like, okay, clearly she has no idea what I'm saying. So I asked for a towel in Spanish, come back with the towel that I wanted. I was like, why were you trying to talk to me in English if you don't understand what I'm saying? And she was like, oh, well, I can speak it, I just can't understand it. And I was like, well, that helps me none. But even science has its own language, and the ways in which we communicate as scientists is heavily influenced by us having an understanding that we're using the same words with the same definition. The ways in which scientists use those words as it applies to whatever field that they're practicing is going to be very different, but the words themselves are going to be the same. For example, force for a rocket engineer is very different than force for a cardiothoracic surgeon, but force is still equal to mass times acceleration, regardless of what your application of it is. I sat down with my dad to have a conversation about how the language of science is used effectively within his job as a rocket engineer, but also how the language of science isn't necessarily effective when trying to communicate with the general public. Can you describe when you hear the language of science, what that means to you?
Especially in research and in the teaching environment, you want to have a language that conveys the uniqueness of the phenomena you're trying to describe and that doesn't get confused with some other similar type of event. So you want to use a term that when I say current flow in an electrical circuit, it specifically relates to a phenomena unique to that environment.
And do you use the language of science in anything other than your job?
There are conversations outside of the job that terms do fall into play. I mean, if we have a power outage on your house, in general terms, it means something to people, but more specifically in my case, I would be talking more about where was the disruption? Was it near term? Did it affect distribution locally, or was it a global, more widespread phenomena? So yeah, there's cases where you get into this discussion in a personal level where you actually use the scientific terms, but that's because I'm familiar and comfortable with it. It would not necessarily happen in normal layman conversation, but since I do it for a living, it is part of my vocabulary and it gets ingrained in there. So, and I'm sure you've noticed it over the years. We'll be talking and I'll throw a term out and you're like, what are you talking about, Dad?
Can you tell me a little bit more about like when other people ask you like, what does that mean? What are you saying? And you have to check yourself because other people, it's not their daily language?
Sure. So let's take phenomena. Last week we had a launch from Vandenberg Air Force Base, which was during the
Space
daylight
Force
hours.
Base.
Space Force Base. You're right. You're right. You're right. You're right. You're right. So anyway, in the course of that event, when I talk to people, I say, hey, we're going to have a launch. And I'll go into detail and say, it's a Atlas V rocket that's launching out of Space Launch Complex 3, and it's carrying this such and such payload. And people are like, what are you talking about? Most people wouldn't even care. But when I talk to somebody about, hey, there's a launch coming up, I throw in that information anyway. All they want to see is the streak flying across the sky and the sound and the noise. I get into the details more than most people need to know. But then again, that's what I've been doing for 35 years. So you don't have to say all those things. I can tell you we're going to launch a rocket from Vandenberg, and it's going to carry a spacecraft that's going to go into orbit and take weather readings. And that's pretty straightforward. Most people can understand that.
Can you tell me a little bit about like what code switching means to you and how like even just your talking in scientific words and like when to use that, how not, is an example of code switching?
So in my daily job right now, I'm a systems engineer. What that means to the general public is that I'm the overseer of all the systems, right? But at my level, I have to do more than that. The guy that's out on his yacht cruising the Pacific Ocean and heard about the launch that wants to come into that hazard area is not aware of any of what I just told you. So one of the systems I'm involved with is area surveillance. So we're in charge of monitoring all air traffic and ocean traffic within the area of our missions. So there's a special part of the coastline of California that we have control of during a mission and operation, which means we have to keep all traffic out of there. It's not essential to the mission. So if you're on a speedboat and you want to run by the coast and watch the launch, it's probably a danger to you because you may be in one of our hazard areas where one of the pieces of the missile is designated to fall or may fall if there's in half. So that whole picture of what's in the ocean, what's in the air, and what's in our space has to be conveyed to an operator doing preparations and execution of a mission. That's kind of the overview I have to take as a systems engineer.
Pablo Picasso once said, "When I was a child, I drew like an adult. It wasn't until I was an adult that I learned to draw like a child." And I think so often we want to break the rules without learning the rules of something. Pablo Picasso was talking about how he wanted to learn all of the rules of how to paint while he was a child. And so as a child, he was painting like he was an adult because he followed all of the rules. But then as soon as he became an adult, he realized all of those rules were worth breaking and should be broken for the world to be changed. So I encourage you to recognize that you have to know the rules of the language of science in order to be able to communicate with other scientists. But you also have to be able to question the language that you're using and whether or not that's the most impactful or intentional language to be used, and if you're trying to bring about the outcomes that you want for your patients. My parents aren't native Spanish speakers, so when I was starting to learn Spanish, I had to learn in a classroom. I had to start by learning all of the rules, all of the different conjugated verbs and all of the different tenses and all that stuff. But eventually, I wasn't just learning for theory, I was learning to have conversations to be able to speak Spanish. Eventually, I had to speak Spanish to somebody else and understand what Spanish they were speaking back to me. The same thing is true about science. When you're in all these classrooms, you're learning all of the rules, you're learning all of the theory, but you're not actually learning how it applies. And just because you learn a rule in one setting doesn't mean it's going to be applicable in this setting. The Spanish that I learned, yeah, it's helpful in some parts of Spain, in some parts of Mexico, but there are definitely parts of the world where I may go and try and speak Spanish and have no idea what I'm talking about because those rules that I learned are not applicable in this. I still am going to be able to figure it out though because I've got some basis for some kind of rules. The same thing applies for science. You have to start somewhere. You have to understand the rules, but from there you can learn how to manipulate the rules and understand what actually matters for becoming a physician. You've already taken the classes. Now it's time to just become a doctor. At the end of the day, the goal is to treat a patient. So you have to be able to also speak the patient's language. You're not at a deficit because you can't already speak the language of science. You're at an advantage because you can already speak the language of your patients. You just have to learn the language of science. Some people have to learn both.